So, section 12.1, we are talking about tangent lines. And one thing, you've heard this word tangent before in everyday language. You've ever heard of somebody going off on a tangent?
Yes.
Yeah, what does that mean?
They go on like rant.
They rant or go off topic, right? They kind of go off topic. You're talking about something, and they go off topic. And so I kind of think of it this way, as I'm talking, suddenly I go off topic. And that right there is a tangent line. Okay? A tangent line is a line that touches a circle at exactly one point. Okay? It touches or intersects the circle at exactly one point. And so in that diagram here, we have line AB is tangent to our circle. That means point B is our point of tangency, because that's the point where it touches the circle. Okay? Now, not only lines can be tangent. You can have a tangent segment, you can have a tangent ray, as long as it is part of a larger tangent line. Okay? So, for example, here, line segment AB is then tangent to our circle, or ray BA is then tangent to our circle. Okay? So it's possible to have segments or rays that are tangent to the circle as well. Okay, well, the first property we need to talk about with tangents, it's probably one of the more important ones here, is that if a line is tangent to a circle, then that line forms a right angle with the radius drawn to the point of tangency. Okay, so we have line AB here. Point P is that point of tangency, and so therefore ray OP is perpendicular to line AB. Okay, and that should kind of make sense for a couple of reasons. First off, let's see if I can flip this picture around here. First off, if you think of the tangent line as the road and think of the circle as a tire, you guys all know that the weight of the car is being forced down, perpendicular to the ground, right? For those of you in physics. Okay, that's how that works. It's perpendicular to that force. Okay. Another thing you could think of is you could think of just think of what would happen if it was anything else. Okay, we're talking about a line. Lines don't bend. Lines are straight. Okay, and so if I take our tangent line here, let's see, and I have my point of tangency, so I'm going to pivot on that point of tangency, and I'm going to pivot this line just a little bit this way. Okay, I curved a little bit, but you get the idea. I'm drawing a line, okay? And the idea there is that if I pivot that line just a little bit, I'm now not only intersecting my circle here, but I'm also intersecting my circle somewhere up there. Okay? A tangent line only intersects the circle at one point. And so if I tweak that line at all, it's going to start intersecting the circle at more than one point. Okay? And we can't have that. So that's why it has to be a 90-degree angle at that point of tangency. Okay? Questions, comments? Doing okay? All right, let's try an example then. We've got that straight again. All right, straight enough. So taking a look at this first example, we know that our two line segments, LM and MN, are tangent. And so that then means that L is the point of tangency, N is the point of tangency. So that means what about angle OLM? What do we know about angle OLM then? We know it's a 90-degree angle. It's a right angle. Let's do that with a thinner pen. Okay. How about angle ONM? It's a 90-degree angle. So, what do you know, or what shape are we working with? Looking at that shape LONM. What shape is that? Don't know that yet. Don't know that yet. You're right, but we don't know that yet. What shape is that? What do we know about it? We're not guaranteed it's a parallelogram. We're guaranteed it's a quadrilateral. All we know about it at this point in our lives is that it has 4 sides. That's it. Okay? The nice thing is, that's enough. Because we know that the 4 angles in a quadrilateral always add up to what? 360. And so we can just write an equation that says x plus 90 plus 90 plus 117 equals 360 degrees. And we can solve that. Now 90 and 90 is 180. 180 plus 117 is what, 297? So I'm going to subtract 297 from both sides. That goes away there, leaves me with x. And what is 360 minus 297? 63. There's the measure of x. Questions? Okay, so then let's go ahead and do the next example. The next example, we're not dealing with a quadrilateral anymore. We're now dealing with a triangle. Okay, so then rather than adding up to 360, what's this one going to add up to? 180. But we still have that tangent segment. DE is tangent to our circle. Well, OD is a radius. That means it has to be perpendicular to that segment. Okay? So we have x plus 90 plus 38 equals 180. So I can subtract 128 from both sides. What's x? 52. Okay? Questions? Now, one thing I want to show you guys, just because I've had students in the past that have asked this, let me bring it back to this problem. Let me erase that blue. Okay. I've had some students who have had questions as far as where that 90-degree angle is. So I'm going to zoom real close here. And so if you remember from that segment or that picture, the red segment there is the radius, right? The black segment there is my tangent segment. Agreed? And then the blue segment there, actually it's not a segment, the blue line there is actually part of the circle. Correct? Okay. That 90-degree angle is being formed by the radius and the tangent segment. I have had students in the past think that I'm talking about an angle formed by the radius and that circle. There is no angle formed by the radius and the circle. Angles cannot be formed by curved lines. Okay? So circles don't make angles like that. We don't make angles in circles using the actual edge of a circle. So that right angle is formed by the radius and the tangent segment, not the circle. Okay? Just want to make sure that's clear. All right. Let's then look at our next theorem, which is really just a converse of the one that we just said. So if we know that a line is tangent to a circle, that means it's perpendicular to the radius at that point of tangency. This converse says that if you know that a line is perpendicular to a radius at its endpoint. Now, there are 2 endpoints of a radius. One is the center of the circle. The other is on the circle. So, of course, they're talking about the one on the circle. Okay? So, if it is perpendicular to a radius at its endpoint, then that line must be a tangent line. It must be tangent to that circle. Okay? That's the only way that that works. All right. Questions or comments on the front page of your notes? Let's go to the back side. At that first example we did, this guy is actually a kite. Okay? And I'm realizing that I'm making a video right now, and by going back to the last page, that actually messed up my video. So those of you watching this video, I'm actually on the last theorem. You'll understand in about 7 minutes. Okay. All right, on the back side, we want to solve for x. Now, notice they give us a 90-degree angle there at B. So what do you know about line segment AB? It's tangent. Yeah, it's a tangent segment. Okay, and we also know that we have the radius we're looking for. They call it x. So what is the length of this segment from C to A? Eight plus x.
Excuse the interruption.
So we have x plus 8 there. Now, to solve for x, yes, they're talking about a circle. Yes, we're dealing with a tangent line, but really we could eliminate all that vocab and just say we're working with a right triangle. How would I find a missing length, a missing side length in a right triangle? Pythagorean theorem. I have no angles, so I can't use that trig stuff. I have no angles, so I don't know if it's a special right triangle. But I have side lengths. I can use Pythagorean theorem. So a squared plus b squared equals c squared. And we needed to know something else, not just the Pythagorean theorem. We also need to know one more piece of information in order to do this properly. Do you remember what that other thing we need to remember was? You have to know the Pythagorean theorem, a squared plus b squared equals c squared, but then you also have to know what? What goes in for c? That is key information. If you're ever going to work the Pythagorean theorem properly, you have to know that the hypotenuse, which is the longest side of the triangle, is always the value of c. Always. So in this case, I have x squared plus 12 squared equals x plus 8 squared. Okay. So let's go ahead and keep solving here. X squared plus 144 equals, well now I've got to take x plus 8 squared. Now notice it's in parentheses. It's that whole thing squared. It's not just x squared plus 8 squared. Okay? You have to use a 4-letter F word from math. Pick the proper one. Remember it? It's FOIL. FOIL is what we need to do. So, to FOIL, we have to take x plus 8 times x plus 8. That's what x plus 8 squared means. Okay? So, we're going to go ahead and FOIL. Now, FOIL stands for, do you remember that part? What does FOIL stand for? First, outside, inside, last. So what that means here is that I would take x times x, because those are my first terms. I would take x times 8, those are my outside terms. I would take 8 times x, those are my inside terms. And then I would take 8 times 8, because those are my last terms. FOIL works great, okay? I don't necessarily do it that way. Yes, I still use FOIL. I still call it FOIL. But the way I think it's easier to think about is like double distribution. I think of it this way. I just say, well, why not just take x and distribute it? So I now have, just going to go ahead and work this out, x squared plus 144 equals x times x is x squared. X times 8 is 8x. And now I take the second term, the positive 8, and distribute it. Okay? I did FOIL, but I didn't necessarily think of it as multiply your first terms, multiply your outside terms. Okay? Because my first terms are x times x. I did that. My outside terms are x times 8. I did that. My inside terms are 8 times x. I did that. And my last terms are 8 times 8. I did that. So I find it just easier to think of it as two distributions. Okay? Questions or comments there? FOIL kind of coming back to you? A little bit? All right, well, we can simplify that down because I can combine like terms. So x squared plus 144 equals x squared plus 16x plus 64. And at this stage, I have a lot of students that are like, well, what do we do with the x squared? Step 1 is calm down. Okay. Step 2 is to just keep doing what you're supposed to be doing. To solve for x, we got to get the x's by themselves on one side, right? We got to get our whole numbers by themselves on the other side. So do that. I have an x squared and an x on the right side of my equation. So let's bring all x's over there. That means I've got to get rid of this x squared by subtracting it away. If I subtract it from the left, I got to subtract it from the right, and look what happens. It disappears. Oh, I worried about nothing. Don't worry about the x squared. Just keep doing what you're doing, and good things will happen. Okay? So I still need to keep going, because I want to get my whole numbers to the left side. So I'm going to subtract 64 from both sides. So that goes away. 144 minus 64 gives me 80, which is equal to 16x. And to solve for x, I can now have to divide by 16. And yep, you're right. X is going to equal 5. Okay. Questions? Well, for those of you who have been telling me for 3/4 of the year that geometry is hard and you really liked algebra, well, here you go. Algebra's back with a vengeance. Okay? And that's going to be true for the rest of the school year, folks. You guys have already seen it in the first half of this unit. We're dealing with formulas. We're plugging numbers in. We're manipulating numbers. That's algebra. Okay? It's not going away. We're going to be dealing with a lot more formulas and a lot more equations going into the end of the school year. Okay? So we can do it. All right? Questions on this? I would like you guys to work the next problem. Follow that same example. Follow that same example. It's the exact same thing. So what we should be doing on this problem. First off, Pythagorean theorem. And this length is x plus 6. So, x squared plus 10 squared equals x plus 6 squared. So, x squared plus 100 equals x plus 6 times x plus 6. So, double distribute x times x times 6, then 6 times x, and 6 times 6, oops, 36. Okay, combine my like terms, so x squared plus 100 equals x squared plus 12x plus 36. I want to get my x's on the same side. Happy day, those go away. I want to get my whole numbers on the same side. So I get 64 equals 12x. Now at this stage, folks, we need to divide both sides by 12. Do not give me the decimal. And the only time you should be giving me decimals as answer is if they ask for a decimal as an answer. Okay? Otherwise, reduce the fraction. That's what we need to be doing. Reduce this fraction. You can reduce it by 2, but then you have to reduce it by 2 again. Or you can just reduce it by 4 at the beginning. 4 goes into 64 16 times. 4 goes into 12 3 times. And so our answer is 16/3. Again, fractions are just one of those things you're going to have to get used to because they're going to help you in Algebra 2. They're going to come back with a vengeance. Questions, comments? Yes, sir. Here we go. I then would like you guys to, let's go down to the bottom. Better not. Let's start here. How would I check if I have a tangent? Let's not skip into, I just do the Pythagorean theorem. Absolutely. So we're going to do this one quick. I would just check, is 7 squared plus 24 squared, does it actually equal 25 squared?
It does.
And it does. Thank you very much. 625 does equal 625. Moving on to the next problem. Okay? All right. So down here we have a new theorem that says if you have two tangent segments, so we have to know that we have tangent segments, and if they meet outside the circle, then those two segments are congruent. Okay? And so if you look back, so moving here, those segments are then congruent coming down to this problem. We have some vocab here. Inscribed versus circumscribed.
Okay, testing the intercom. Can you hear me?
I sure can.
Okay, thank you.
Thank you. Inscribed versus circumscribed. Inscribed sounds like it's going to be inside, right? So that's exactly what it is. Inscribed is inside. Circumscribed. Remember I talked about that prefix circum? What does it mean? It means around. Around the outside. So circumnavigated the globe, right? Circumference. Okay? So the circumscribed, okay, you're giggling. So yes, it's still around. Okay, it's still around. All right. So, circumscribed, we have a circumscribed triangle, because we have a triangle drawn on the outside, right? And then we have an inscribed circle. Now, the key to both of those words is that they have to touch the sides, always, okay? So, the triangle or the circle always has to touch everything all the way around here. All right, now I did not get through the whole thing before lunch, so we will finish our last two examples after. All right, so we have two examples to go through quick. We talked about inscribed versus circumscribed. And so if we take a look at this example here, it says that we have a circle O that is inscribed within our triangle ABC. So that means that the triangle is then circumscribed around the circle, right? Triangle's on the outside, circle's on the inside. But since we have that, since we know that the circle is inscribed in the triangle, that means that each side of that triangle is a tangent. Each side of that triangle is a tangent. And so, if I look here closely, I see that D is my point of tangency, F is my point of tangency, and E is my point of tangency. So, line segment AD is then going to be congruent to line segment AF. If you're wondering why, refer back to the theorem right above this problem. Okay, they meet outside and at point A, so therefore those two tangent segments are congruent. FC is congruent to CE, and DB is going to be congruent to EB. So what's the length of AF? 10. What's the length of CE? 8. What's the length of EB? 15. They want us to find the perimeter. How do you find perimeter of a triangle? Add up what? All the sides, right? Think of it this way. Perimeter and circumference mean the exact same thing. Except perimeter is for polygons. Circumference is for circles. Okay? But they mean the exact same thing. So it's that distance around our shape. So to find that, I am simply going to take my perimeter equals 2 times 10 plus 2 times 8 plus 2 times 15. If you prefer to actually take 10 plus 10 plus 8 plus 8 plus 15 plus 15, you can. It's the same thing. This is a little faster. And so our perimeter is 66 centimeters. Questions? Got one more. Oops. Right next to it here, we have this one. Now this one's a little bit different. We know we have tangents, but they tell us, and it's off screen right now, but they tell us that the perimeter is 88. Okay? So they tell us the perimeter of the triangle is 88. We want to find the length of QY. So I'm going to go ahead and call QY X. Okay? Well, if QY is X, what's the length of QX? Also X, yeah. Because those two segments have to be congruent. They're tangent segments that meet at the same point outside the circle. What's the length of PZ? 15. What's the length of YR? 17. And so we're going to do this the same way we did before, except now, rather than saying P equals, I know that 88 is going to equal, that's my perimeter, it's going to equal 2 times X plus 2 times 15 plus 2 times 17. Now again, if you would rather say x plus 15 plus 15 plus 17 plus 17, you can. Okay? But I'm trying to shortcut stuff. And so then we'd take that and we'd solve for x.
12.
It's 12? Okay, cool. Questions?